Good evening, everyone. My name is Faizi Bagarov, and this is a 6-minute lecture on word vectors. So in the next 6 minutes, we're going to talk about a few topics. We're going to talk about unstructured data and what it is. We're going to cover what is natural language processing and natural language processing tasks. And we will cover the concept of word vector. So unstructured data. Prior to about mid-2000s, the data was mostly stored in relational database where in the structured format where all the rows had to be identified by a unique identifier called primary key, and data in general had to be broken down into smaller pieces and then connected to each other by means of relationships or foreign keys, and hence which was called data model. Hence the name relational model databases. From about 2000s, where there was an influx of the of data from the upcoming web e-commerce websites, from the more and more businesses started popping up on the web, and more videos, more social media feeds, and so on and so forth. All that data started coming in, and that data had to be processed by something else that already existed at a time. Hence, new platform Google was the first one to come up with the NoSQL database called Bigtable, and then a myriad of NoSQL database appeared. But the concept, but the idea of those databases was to accommodate the unstructured data, meaning the data that didn't have any model in it, right? It was not identified by any unique identifier per se, and essentially it was a free text, right? Reviews, books, emails, all that constitutes unstructured data. And semi-structured data is a combination of both. In semi-structured data, you store text in certain formats which accommodate the data but not necessarily follow the same standards as structured data does. So for processing unstructured textual data, a natural language processing is used. Natural language processing is a field of computer science and artificial intelligence concerned with making computers process natural human language. There's also computational linguistics, which is the field of using computers to understand the language, hence the natural language understanding. The natural language processing is comprised of several tasks. So there's basic text processing, information extraction, and information retrieval. So with basic text processing, you're mostly concerned in breaking down the sentence into the separate words, so-called tokens, and identifying different parts of speech. In information extraction, you're concerned with questions. You're concerned with questions of retrieving and identifying and retrieving entities from that text. So examples could be identifying that the apple that is being mentioned in the article is actually fruit and not the company, or the shell is actually the company and not the seashell. And finally, information retrieval has to do with the activities we commonly associate with search. And today we will talk a little bit more details about word vectors. So in simpler terms, a word vector is a row of real valued numbers as opposed to just dummy numbers, where each point captures a dimension of the word's meaning, and where semantically similar words have similar vectors. So in other words, if you have a text, if you digitize that text, meaning that you will convert each word into numbers, and each word can be represented by an array with a few dimensions. So it could be, if it's a 3 dimensions, so for example, the word woman could be represented, let's say, as 57, 80, 176, which would be coordinates of the vector in the 3 dimensions. Word vectors represent words as multidimensional continuous floating point numbers, where semantically similar words are mapped to proximate points in geometric space. In simpler terms, a word vector is a row of real valued numbers, where each point captures a dimension of the word's meaning, and where semantically similar vectors have semantically similar words have similar vectors. This means that words such as wheel and engine should have similar word vectors to the word car, whereas the word banana should be quite distant. The beauty of representing the words as vectors is that they lend themselves to mathematical operations. So, for example, we can add and subtract vectors, and the typical example here is showing that by using word vectors, we can determine that king minus man plus woman equals queen. In other words, we can subtract one meaning from the word vector for king or maleness and another meaning femaleness, and show that this new word vector, king minus man plus woman, maps most closely to the word vector of queen.